So welcome back to the class everyone. I'm Pooja Devi. I work as assistant professor in Mlritm. So today I'm going to teach you the topic of DVC. In DVC we have already discussed the previous topic of exact and non-exact differential equations. So now since we have moved further, now we are discussing exact differential equation, third problem. We have already done two problems on it, right? So this one is the third of previous class continuation, right? So in the third problem, proceeding with the third problem, let us once again recap what is exactness condition and what is called a exact differential equation. If the equation is of the form mdx plus ndy equal to 0, then we say it is an exact differential equation provided with the condition that dou m by dou y is equal to dou n by dou x, right? I think this is already visible in the slide here, okay? So the equation should be of the form mdx plus ndy equal to 0, where m and n are real valued functions, and it should satisfy the exactness condition. Then you can find the solution, that is integral of mdx plus integral of ndy is constant, right? So proceeding with the solution, here my m value is how much, ma? 1 plus e power x by y, right? And n value is what? E power x by y, 1 minus x by y. Here in n you need not multiply it, we can directly take it as a term, okay? Let us see how we are doing that. So dou m by dou y, as I have said in previous class, if you remember, here you are taking m with respect to partial differentiation, that is you have to differentiate m, or you can say you have to partially differentiate m with respect to y. So in 1 plus e power x by y, one differentiation is anyway 0, and e power x by y, since we are differentiating it with respect to what, ma? Y. So what will become constant here? X will become constant. So 1 by y differentiation is what? It is minus 1 by y square, right? Next, in dou n by dou x, what we are doing? We are differentiating n with respect to x. So here y should be constant. One more thing you should always remember is that when you are performing partial differentiation, only with respect to that independent variable you are performing the differentiation. Other variables will be given zero significance, that is they are becoming constant. You have to take them out of the term, right? In dou n by dou x, y has no place, so y should be written out, okay? When you are taking e power x by y into 1 minus x by y, see, let us perform uv here, okay? Don't multiply it and mess up. So if you think u is e power x by y and v is 1 minus x by y, if we perform uv dash formula, that is we know the chain rule, right? uv whole dash uv differentiation formula, okay? u into v dash plus v into u dash. So u into v dash, so differentiation of v, 1 minus x by y, one differentiation is anyways 0, right? Now what is remaining? You are having minus x by y. In minus x by y, what is here? Y should be thrown out because it is constant, so write y outside, minus 1 by y. Now differentiation of what is this, ma? X is 1. See, here I have written mistakenly u, it should be written e power x by y. So what we are getting? E power x by y into minus 1 by y. Okay, I have written once again down. Now next what we have to perform? Vu dash. So Vu dash, that is 1 minus x by y into e power x by y differentiation should be done with respect to x. So 1 minus x by y into e power x by y, with differentiation is with respect to x. So x differentiation is what, ma? 1. 1 by y. So what you are resulting, if you take this common, e power x by y here, okay, I'll write it in one more step. Actually this can be done directly, but you people should understand, that is why I'm writing once again. See, here I'm taking minus, okay? I'm just multiplying here. There is no rocket science. This e power x by y into 1 by y is being multiplied with 1, and this is minus again e power x by y into 1 by y. This one again I'm multiplying. What it is resulting? X by y square. So if you see, minus plus gets cancelled. So what it is remaining? E power x by y into x by y square. I think you can even write it like this, e power x by y into minus x by y square. Hence what we got, ma, dou m by dou y is equal to dou n by dou x. So which means that our exactness condition is being satisfied for the given problem. So once you are done with the exactness, proving exactness, what you have to do, you have to find out the solution. So what is the solution? Integral of m dx plus integral of n dy is the solution, right? Is equal to constant. One thing here you have to remember is that this terminology should always be written in the formula. Remembering only this cannot lead to the whole answer. You have to write here that y is constant and only those terms of x which are independent of x. This terminology should be written always. Okay. So I am doing the next problem, next solution here, since I don't have sufficient place here. Okay. Yeah. Now what is m here? This is m, right? So integral of 1 plus e power x by y into dx plus integral of n. Anyways, in n, I'll write here n, okay, into dy is equal to c. Okay. Anyways, in n we don't have any term which is independent of x. You see in e power x by y, x is there. In x by y also, x is there. This term is being multiplied. So if you take or don't take also, doesn't matter. So we are not getting any term here. So this is anyway 0. Now we have to perform integration with respect to m here. That is, we are taking the m term. In m term, what he told, y is constant. So integral of dx is what, ma? X plus, next, e power x by y integration is what, ma? E power x by y integration is by x by y only, no? But what we said here, that y should be constant. So again y is thrown out, right? So which implies x plus, if this y by x is written up, what you are getting? Yes. So this y gets cancelled. So what remaining? X plus e power x by y by x is equal to c. So you are getting the final solution, right? So this will become your final solution. I think I can write it neatly once again. Just give me a minute. See, one thing you have to remember while doing substitution or while integrating, you make sure that you don't put many steps. Actually, they can get cancelled in even one step. See, if I want, I can write it like this: x plus e power x by y. So integration of dx is anyways x, right? X plus e power x by y, and this integration is again what, ma? X by y, provided what I told here, y is constant. So I am writing this 1 by y out. Okay, so when this is going up, what it is becoming? Y by x into e power x by y. 1 by y is equal to c. Here c is there always. Okay, the c is there. So this one is getting cancelled, which means I'm getting x plus, or you can even take common and write in this way. Is this okay? Are you clear with the solution? Okay, I think we can move forward. Proceeding with the fourth problem. Here also we are doing the same process. You should always remember that whatever the problem is, we are almost following the same solution. First we are finding out m dx plus n dy, where m and n are real valued functions. It is mandatory that it should not be in this form. If it is in this form, what we should do? We should perform cross multiplication so that we can get the equation in terms of m dx plus n dy equal to 0. And provided if it is satisfying the exactness condition, then you can happily find the solution, where for m you are taking y constant and for n you are taking only those terms which are must, it should be independent of x, which means it should not consist x, like x, y, x square, y. These all terms cannot be considered. Okay, let us solve this problem. So here just cross multiplying, what you are getting? X cube secant square y into dy plus 3x square tan y into dx is equal to cos x. Is this ma? Anything we can do? See, if you are multiplying, cross multiplying, this dx is being multiplied with this. So how can we write it? Any idea? At that time, what we can do is that you take like this: x cube secant square y into dy by dx is equal to cos x minus 3x square tan y. If you take it like this, any problem? We can write it like this. At this time, if you multiply dx here, that is dx into cos x minus 3x square tan y plus multiply this dx here, and if you are taking this dy this side, then it will become minus. So this equation we are getting minus. That way is also okay, or you can simply put this dy to the other side. That is, you take this is becoming plus, right? If it goes here, it is becoming minus. So instead you take this term only to this side, so that it will become minus. So this will become plus and this will become minus. I hope you have understood what I have done just now. See, in order to get the equation in terms of mdx plus ndy, any manipulation is allowed, provided you don't change the terminology of the given equation. You either multiply this directly with this, but you are not getting dy and dx terminology. Hence, what you can do, the alternate is that you send this term to this side, or else you take this term to here. It is your wish. I am taking this term here, so that I can easily get the equation in terms of mdx plus ndy. So what is my final equation? 3x square tan y minus cos x into dx plus x cube into secant square y dy is 0. Now am I getting correct equation? Okay. Let's check with the exactness condition. So this is my m value ma, and this is my n. Right? This equation is of the form mdx ma. So what is m differentiation with respect to y? So since he is saying y, you can happily take x constant. So throw 3x square out. So tan y differentiation is what ma? Secant square y. Okay. Cos x differentiation is anyway 0, because here my differentiation is with respect to y. That thing should always be filtered in your brain, that for partial differentiation, always except the independent variable, other variables will become constant. Then dou n by dou x, you see ma, in dou n by dou x, again I can happily throw secant square y constant outside. So differentiation of x cube is how much ma? 3x square. So we are getting, again, exactness condition is being approved for this problem. So hence we can find the solution without any condition. So integral of mdx plus integral of ndy is equal to c is the solution. So if you take m here, so what is my m here? 3x square tan y minus cos x. So you have to take the m and integrate it with respect to what ma? With respect to dx. Again that same terminology, that y is constant. So you have to throw tan y outside. First let me write m in terms of this. Integral of 3x square tan y minus cos x. This should be integrated with respect to dx, and then you take again n, which should be taken which are independent of x, right? C. So is it independent of x? No. So answer is 0, right? So what we have to do here? Here y is constant, so throw y outside. Tan y is being thrown out. Then integration of 3x square is what ma? 3 into x cube by 3. Next, cos x integration is sin x minus sin x is equal to c. So this 3 is being cancelled. So what you are getting the solution ma? Finally, tan y into x cube minus sin x is equal to c will be your solution, right? In the whole process, I am just recalling once again. See, here procedure has already been written with blue. blue ink, the procedure has been written. Only thing you have to remember is that while finding out the exactness, you should make sure that dou m by dou y should definitely be equal to dou n by dou x, because when only this condition is satisfied, only then you can find the solution. If this condition fails, then there is no point of finding solution, because it does not accept. That is not the way we do the problem. It is mandatory that you should go through the exactness hurdle. Only then you can find the mountain called solution, right? Now, discussing further, we have integrating factor. Okay, so what is integrating factor? Basically, till now whatever equations we have seen, they all are having exact differential equation, that is, it is satisfying the condition of exactness. Now what do you mean by exactness condition? This should be on your tongue tip. If I say what is exactness, you should strike in your brain with a hammer that dou m by dou y is equal to dou n by dou x is the exactness condition. So there are chances that every equation does not satisfy exactness condition. There may be some equations which are non-exact. So when do you say an equation is non-exact? If it doesn't satisfy the condition dou m by dou y is not equal to dou n by dou x, is equal to is being replaced with not equal to. If it is equal, happily we say that it is exact and we find the solution. But if it is not equal, what we can do? If you think of an example, you think of a student who is not studying, okay, their parents will not leave the student. They will take to a tuition, or they will give him some coaching lecture, something like that. So here what we are doing, we are giving a differential equation a different kind of coaching. That coaching name is called integrating factor, or you can say that magic with which it will become a exact differential equation. If you are multiplying an equation mdx plus ndy equal to 0, which is not exact, with an integrating factor, then that equation will result in a exact differential equation. Here exact means this should be in your brain. So to make it exact, multiplying with some factor, for now you assume it is some factor in terms some term, okay, it can be 2xy, 3x square y, some term through which it is becoming exact. Some manipulation is being done so that this can be like equaled. Okay, that manipulation we are naming as integrating factor. Okay, integrating factor means what, madam? Again, factor. Why did factor come? So these all what you are seeing here, these all are called factors. Okay, so that factor which is being multiplied with equation is being named with integrating factor. In one and only one term, if you want to remember, an equation which can be made exact though it is non-exact, such magic can be done only by the integrating factor. Okay, so that is the introduction for what is integrating factor. Now why these all are there, ma'am? Like 4 variants. In perfumes we all have different variants, right? Similarly, all equations will not be of same. Every person is unique, every fingerprint is unique, there is no match. Similarly, every equation here can also have different kinds of variants. So depending upon your interest, you use the perfume. Here, depending upon the equation, we choose the integrating factor. For the appropriate equation, appropriate integrating factor will be selected. Now, how will it be selected is the procedure which we are learning today. Suppose you just see through definition once again for a recap. A function which is selected in order to solve the given differential equation, sum of the integrating factors to convert a non-exact differential equation to exact are given below. Okay, if the equation is homogeneous and provided mx plus ny is not equal to 0, then 1 by mx plus ny will be the integrating factor. If the equation is of this form, that is y into function of xy into dx plus g into function of xy into dy equal to 0, and provided mx minus ny is not equal to 0, then 1 by mx minus ny is the integrating factor. If the function is total in terms of x, then we use the integrating factor e power integral f of x into dx, and if it is respectively in terms of y, we use e power integral g of y into dy. For instance, today we are going to discuss the first method. In exam, there are chances that you may not particularly identify which is the integrating factor. By having some trial and error also, there is no problem, because it doesn't take a long time to figure out the integrating factor for the particular identical equation. Okay, assume I'm going to the solution here. I'm having first problem here. Now how will I know that which integrating factor among these is satisfying this variant? Suppose this is one student and these are 4 perfumes. Okay, which perfume will he like? This is rose, lemon, lavender and jasmine, whatever. Okay, now how will I know which perfume will he select, or which variant should I take? So it depends upon his choice. Here this equation will depend upon the variant on what it is applicable. So here I am taking the first one, that is homogeneous. Now what do you mean by homogeneous? Homogeneous in sense, every term in the equation will have the same degree. If you see the equation carefully, here my degree for the particular term y square is what ma? 2. For x square is also 2. For xy also it is 2. How, madam? See, 1 plus 1 is how much ma? 2. Again here 2. So if an equation is having all terms of same degree, then that equation is called a homogeneous equation. Assume if here I am having y cube plus x square y plus yx square plus x cube, then this is an homogeneous equation of degree 3. Why? Because here the degree is 3, here also it is 3. How 3? 2 plus 1, 3. So indirectly also you can get like this. That you should remember. You shouldn't confuse that, no ma'am, here it is 2. No. If you multiply by using the rule of a power m into a power n is equal to a power m plus n, here you can add this using that property. So 2 plus 1 is 3, right? Actually this is not particularly applicable here. Exponential rule is not applicable because these two variables are different, but the concept behind is that multiplication can be done in such a way. This relation is not applicable to this relation, since there are two different variables and here we are having same base. This is exponential, this is differential equation. Only thing I told is that you can easily remember how to find degree. Okay, so since you are having a homogeneous equation, you can use the first integrating factor. Now what is the first integrating factor as per this slide? 1 by mx plus ny. Now we can happily use 1 by mx plus ny as the integrating factor. But one more thing you should check is that, is mx plus ny is equal to 0? Because if this becomes 0, then what will happen? 1 by 0. This is not valid. This does not make an integrating factor. To be more appropriate, it does not make a sense because you cannot multiply this with the equation, right? So it is very mandatory that mx plus ny should not be equal to 0. So if it is satisfying two conditions, what are the two conditions? First thing is that the equation should be homogeneous, and the second condition is that mx plus ny should not be equal to 0. Then you can say that the particular equation can have the integrating factor 1 by mx plus ny. So we are using now 1 by mx plus ny as the integrating factor. But how will I use the 1 by mx plus ny factor? First I should check whether it is exact. If it is exact, then what is the use of integrating factor? We can directly find solution. So first let us check the exactness condition. So first you take the equation is of the form mdx plus ndy equal to 0. Now what we have to say, where m is y square and n is what ma? X square minus xy minus y square. Okay, in m and n these are real valued functions. Okay, so what is the exactness condition? Dou m by dou y is equal to dou n by dou x is the exactness condition. Let us check whether it is satisfying. So what is dou m by dou y? We are getting 2y. Okay, dou n by dou x, how much we are getting ma? 2x minus y. Y square differentiation is 0 because partial differentiation with respect to x, that is why y will become constant, so it will become 0. So clearly you can see that it is not satisfying the condition, that is dou m by dou y is not equal to dou n by dou x. So therefore what we can say, the given equation is non-exact. Now the student is not studying, we cannot leave him, so we will approach him to a better coaching class, that is we are giving the name of integrating factor here. So my integrating factor here is what ma? 1 by mx plus ny. Now why 1 by mx plus ny? These two conditions are being satisfied. That is why I am able to use integrating factor. First condition is what ma? Homogeneous. The equation is homogeneous. And what is the second condition? Mx plus ny is also not equal to 0. If you add m into x plus n into y, it is not, you are not getting 0. Are you getting 0? You are not getting 0. So you can even, this condition is also bypassed. So which means we can use integrating factor 1 by mx plus ny happily, right? Now how we will use? Okay, you found the integrating factor, very good. Now how will we use this for our equation to make it exact? Till here in this problem, the equation is non-exact. That is one thing to be noted as well as remembered. Till here process, the equation is non-exact. From here we are trying to make it exact. How you see? So multiplying this given integrating factor with the equation. Always remember, when you are taking the problem, take the given equation as equation 1. Okay. So this equation should be multiplied with the integrating factor. So multiplying with integrating factor 1 by mx plus ny for equation 1, right? So what you are getting if you are multiplying like that? Did you get one doubt that how will you multiply directly 1 by mx plus ny? You should find what is 1 by mx plus ny. You shouldn't be in a hurry to directly multiply integrating factor with the equation. You know m value, you know n value, you have to find the integrating factor, then you have to multiply it with the given equation. Okay. So now let us find what is integrating factor first. So what is my m value here? Y square. So y square into x plus n value is what ma? X square minus xy minus y square into y. This is my n value multiplied by y. So what I am getting? 1 by y square x plus x square y minus xy square minus y cube plus x square y, okay, plus y square x minus xy square. Can I cancel this both? The term is little bit reverse. Okay. So what I am getting ma? 1 by x square y minus y cube. Is this I am getting? I think I can take y common from here. So what I am getting? 1 by x square minus y square. So this is my integrating factor. So once you find the integrating factor, it is important that you take the m and n values into the integrating factor and find it. This is also applicable for any integrating factor. For example, you are getting this integrating factor also, you have to take m and n, find out, then only the resulting will be the integrating factor. You cannot directly use this. You cannot directly multiply mx plus ny because there is no m here in the equation. You have m value, you directly cannot use m. Okay, that is one thing you should remember. Next, once we have find the integrating factor, so what is our integrating factor? Let me remove this all so that you can get some space here. So therefore what my integrating factor is ma? 1 by y into x square minus y square is my integrating factor. Now I can multiply this with my equation. Okay. So now let us multiply. So 1 by y square. So first term m is what ma? Y square by y into x square minus y square into dx plus x square minus xy minus y square into dy by y into x square minus y square is equal to 0. So this is the new equation you are getting. Now we have to check whether this equation will turn out to be exact or not, because this equation 2 and equation 1 is different. This is non-exact. We are trying to make this equation exact by using the magic of integrating factor. Okay. Now here we can cancel y, no? So what will be the equation here? Directly I'll write here itself. So equation will be what ma? Y only, no? Here I am writing. So y by x square minus y square into dx plus x square minus xy minus y square by y into x square minus y square into dy equal to 0. Now taking integrating factor, again you have to perform the same procedure of finding exactness. Check whether it is exact or not. So how will you know whether it is exact or not? Again the same condition, dou m by dou y is equal to dou n by dou x. Here m and n values are changing because this is new equation, no? That is why you name it as m1, because previously I have already taken what is m, right? You cannot again put same m because both m's are different. This m is y square. Again if you put m is y by x square minus y square, that is not appropriate, so you name it as m1. And what is my n1 ma? X square minus xy minus y square by y into x square minus y square, right? Now you check whether it is exact or not. Dou m1 by dou y. Okay, we will go to next slide and do that. Okay, what is my m1 ma here? Y by x square minus y square. m1 is y by x square minus y square. Okay, so performing dou m1 by dou y. Ma, this is, we are doing previous problem, okay? This is not applicable here, we are doing previous problem, okay? So dou m1 by dou y, we have to use here u by v rule formula. U by v formula is what ma? Vu dash minus uv dash by v square. This formula you all know, right? So first you take v, this is my v, no? X square minus y square into y differentiation is what ma? 1 minus u into, what is my u here? Y into v dash. So differentiation with respect to y, my x square will become 0. So here I am getting minus 2y by v square, that is x square minus y square whole square. So what I am getting, dou m1 by dou y is equal to x square minus y square minus into minus plus 2y square by x square minus y square whole square. So dou m1 by dou y is equal to what ma? X square minus y square by x square minus y square whole square. This is my dou m1 by dou y. That is nothing but 1 by, I think 1 x I can get cancelled here. Now let us check with what is dou n1 by dou x. So what is n1 here? X square, it is little bit big, but no issues, we can do it. X square minus xy minus y square by, this is differentiation with respect to, yes. So continuing, there was a little confusion previously here. See, my integrating factor is 1 by y into x square minus y square. While multiplying with the equation, I have already cancelled here. So I was searching where 1 was, y was. No issues, we can directly take it. So x square minus xy minus y square by x square minus y square is my n value, no? See, anyways, 1 by y will be thrown out only because it is constant. Now directly I am taking it out. Did you understand what I did here? See, I am having here 1 by y. Okay, assume this is 1 here. So 1 by y can directly be thrown out since it is constant. Why taking it into the problem? Okay, now you perform uv rule again. The formula which we have written here, this one, okay. Now this one is v, this one is u. So if you perform again, so what you are getting, v into u dash. So x square minus y square into u dash. So what is u dash? You have to differentiate it with respect to x, that you should remember always. Minus x, this y will become 0 anyways. Minus u into v dash. So x square minus xy minus y square into v dash is 2x by x square minus y square whole square, right? Again, if you see here clearly, you just multiply these terms. What you are getting? See, x square minus y square, 2x minus x is what ma? X only. So that is x square minus y square into x minus of, here you are, what you are getting ma? 2x cube plus 2x square y plus 2xy square, right, by x square minus y square whole square. So here plus x cube, no, Here you are getting plus x cube. So plus x cube minus 2x cube. How much it is? X cube minus 2x cube minus x cube. We can do it once more here. 1 minute. So performing dou n1 by dou x. Again you should get what ma? 1 by x square minus y square. Only then we can say that the given equation is exact. After performing the exactness condition, then you have to find the solution of integral m dx plus integral n dy is equal to c, which will result to the final solution of the given equation. Okay, we will try to find out dou m1 by dou y in again next class. Till here you just remember that we have to find the integrating factor, multiply the integrating factor with the equation, and then we have to find the solution. In next class again we will come back finding the integrating factor, whether it is exact or not by the given equation. Right? Thank you.